let's go ahead and start taking a look at this. On some of these, we are going to be doing some estimating, and that's okay. We're going to get it as close as we can, and we're going to call it good. So let's think about our x-intercepts. Top one on the list up here. Where do we have x-intercepts for this graph? Sure we're clear. I'm going to count this as 1, 2, 3, 4. So that's -1, -2, -3, -4. Just labeling things so that we're clear. We're counting by the same stuff. I'm just counting by ones. So where do we have x-intercepts? And you can tell me if it's between things. Between -2 and -1. So there's one of them. And between 1 and 2. We're estimating, I'm going to say those look about maybe 1.6, 1.7, 1.5. As long as you tell me something between 1 and 2, I am not going to be petty about it. Just don't tell me that's 3. So we have x-intercepts at -1.60 and at +1.60. They're very similar. Very symmetrical. How about y-intercepts? Where are those? 0, -2. Perfection. 100% right there. 0, -2. Okay. Here comes one of the ones we struggled with before. What is our domain? How far left does it go? How far right can I go without picking up my pen? Yes, good, I heard it. So I can go all the way left. I know those arrows are pointing really far up. So I know these guys are pointing really, really up, but they are still going out. So it is still going out and over. So this does go all the way over to -infinity. Same thing to the other side. It goes out to +infinity. So I can use absolutely any x value in the entire existence of the universe. -infinity to +infinity, or you can say all real numbers, funky looking R. I don't care how we write it, just that we write it. How about our range? -3 to infinity. This is as low as we can go here, and I can go up as far as I can imagine. So our range goes from symbol, our -3 to infinity. We always put it smallest to biggest. Again, I am not going to be petty about our parentheses. We've got our numbers, especially if we've got our numbers in the right order. I'm happy with it, and we can do with parentheses, brackets, whenever we need to. So then let's look at our extrema. Where do we have an extrema or an extrema? We're looking for either a little baby mountain or a little baby valley. What do we got? I actually already have one of them marked. I was going to say, we've got a little baby mountain right here. And we've already got the top of the little mountain marked. Our y-intercept is also a, what kind of point is that? It's on the top of the mountain. It's a maximum. Is it an absolute maximum or a relative maximum? Relative. because it is a relatively high point. It is higher than all of its neighbors. It's just not the tippy top ever. So we have a relative max at that 0, -2. Our y-intercept is also an extrema. They can be more than one thing. What other extrema do we have? Our -1, -3 is one, definitely. So -1, -3. What kind of extrema is that? It's a minimum. It's an absolute minimum. This is one of the rare cases we have more than one absolute minimums. Because where else is an absolute minimum? On 1, -3. They have the exact same y value. It's the very, very lowest it goes. They're just twins. So we're at 1, -3. They're both absolute mins. And that's okay. It can happen. It's not super common, but it does happen. Yes, sir. For when we're trying to identify the extreme, if we ask you to tell us what it is as well, yes.
I'm saying like they just have it as
Oh, not necessarily, not for this, I just didn't put the words up there, but like on homework 3 we had where we had to identify all the extrema and give the most specific name, that would be the most specific name. Which I'm going to pass that one back today. All right. How about our end behavior on here? That's our newest piece. We usually chart it with our as. And we talk about one of our arrows at a time. So we're going to talk about either the left arrow or the right arrow. It doesn't matter which one we do. I have a tendency to go left to right just because that's the way we read. But some people like to go right to left because right is positive and it's sometimes easier. But I'm going to say my left arrow, as x approaches -infinity. As x gets smaller, what happens to my y? Where does it approach? As I go left, as my x's get more and more and more negative. What happens to my y? Where are they going? Up. As I come more and more this way, that graph is going way up. By the time I'm over here, it's atmospheric. So it's going up, real fast. So as x gets really small, my y gets real big. So we just say it's positive infinity. That's talking about this left arrow over here. That's this guy. So to do the opposite side, we say, well, instead of x being negative, what if x is just really, really big and positive? What happens with my y's then? What happens as my x's get really, really big and come this way? Is it going up or is it going down? Or are you going straight sideways? Up. So if it's going up, that's when we say it's approaching positive infinity. We have 2 last questions on this, and I'm going to toss one at you that's not up here. Oh, snap, what? Is this a function? That was like the very first day. We talked about, is it a function, is it not a function? Use our fancy schmancy stick test. Is it a function? Did I ever cross more than one time? So is it a function? It passes our vertical line test. So yes, just writing it out. So it passed our vertical line test, so then we can do the second one. Is it a one-to-one function? I do. Nowhere does this one actually work as one function. It takes one failure for it to be a no. It fails our horizontal line test. And then the last one I'm going to ask, it's not up here. What kind of symmetry does this have? Point, line, or neither? So when we have line symmetry, what that means is I can fold this thing in half. This is where I'm sitting. Not that. So if I take our graph exactly as it is, and I can fold it in half and make it line up, that's line symmetry. It is folding on that line right there. That's why it's called line symmetry, is it's folding across that line to line back up. If I could spin it, that's when we have point symmetry, because I would be spinning it around a point. So if I can fold it or flip it, just because I don't want to fold my thing, then it counts as line symmetry. So this one has line symmetry. So just wanted to kind of touch on that one. Okay, questions on the bell work? Because what we're going to do today is you guys are going to have a lot of time to work on the review. If you want to, we can work some together on the board, but honestly, I think it's going to be more helpful for you to practice on your own. I am going to get the answer key to the review posted as soon as I scan it, because honestly, I don't think I've scanned it yet. I have it written, I just don't have it posted yet. And I'm going to get homework 3 posted, so we have all of that. So we're not taking notes today. You're going to have the whole time to work on this review. If you need a copy of the review, I have extras right here. If you are still missing any homework assignments, I have a few extras. I have 4 extras, but I can always make copies of it. So use this time. Work on stuff. Take a look at it. We are going to be doing the quiz tomorrow, right at the start of the period. We're not going to have bell works. So you're just going to come in, you're going to drop in your review, and we're going to start the quiz. I don't want us to have to be rushing for time at all. So take a look at this stuff. If you got questions, I'm 100% happy to help. I would love to help you. But I want you guys to try on these. So let me get the answer keys posted and get these passed back. And then if we have any that we want to work together, we can try.